Okay, video number 14 of the How to Wire Schneider PLC series. We are still dealing with the Modicon M221 family, which is what this one has been all about. And today we're going to look at wiring analog current outputs using a cartridge expansion on this PLC set. The cartridges are a specific model to the C or the CE family that they're going to have. And what it is, it's a removable faceplate on the front. You stick a screwdriver in, you pop out this faceplate cover that comes off, and then you take your cartridge expansion, whatever you bought, you place that cartridge expansion in. It's still going to make connection with the back plane over there. Press it till it clicks, and that's it. That's as much installation as you need to do. It takes up no additional rack room on your DIN rail, so it's a nice, easy way when you only need a small number of expansions. The one that we are going to be looking at is going to be a 4 to 20 milliamp output that we are going to go and have. And it does need to go and have a load impedance of no more than 500 ohms. It cannot go and deal with any sort of load that's going to be a super high impedance for it to be able to go and deliver that amount of current out to it. It does have a resolution of 12 bits, that's 4,096 steps, and then what we can do is we can take all of that 4,096 steps, we can scale it in as raw data inside of our PLC from negative 32,768 to positive 32,767 that you are going to go and have. Conversion time is going to be relatively long compared to voltage, 20 milliseconds. Total system time is going to be 40 milliseconds, so it's fast, but it's not as fast as some of your super high-end, M580s and stuff like that you are going to go and have. But it's still very good for what most people are going to be looking at. Smallest output value or smallest change that we can see is going to be all the way down in the microamps. So we're talking in the millionths of amps over there, 3.91 microamps of change that we can see out of this thing at a time. Okay, let's move on to the actual wiring that we have. Inside of the manufacturer's data sheet, they do show that it's going to be a 3-terminal device. All of these devices that we have, the cartridges do show up as 3-terminal devices. There is, however, going to be unused terminals. And over here they have got NC. NC stands for not connected or no connection. Connected. It is a little bit of a misnomer. It would have been nicer if they would have done like an NX or something like that, because NC sometimes gets misinterpreted by electricians as being a normally closed. That's off of there, but in this case it stands for no connection. So now that that's out of the way, we'll take a look at the rest of these components. They just show that we take a 4 to 20 milliamp signal, whatever it is. The negative goes into the ground. The positive gate goes into the AQ0I or AQ1I that we are going to have. So this is going to be the first bit. This is going to be the second bit over here. And they do show that we've got this dotted line around here indicating that this is going to be a shielded style of cable. All right. Let's take a look at this thing in the field over here. We see that we have got our cartridge, which has been inserted inside of here, the 4 to 20 milliamp output that we have over there. If we zoom in, we can go and see that we've got the not connected terminal, the ground, AQ0I, AQ1I over here. So those are going to be the 2 terminals that we're going to be connecting onto in this case over here. All right, we'll zoom back out over there, erase some of that. And let's go and bring our cables in. So over here, we see that the very bottom cable is going to be 4 to 20 milliamps to a field device. So we want to feed that directly off of this card over here. The way that we do that is we are going to start by taking our shielded cable. We're going to go and ground down our shield, and we're going to go and take our internal cable bond, if there is one. Not every cable has an internal cable bond or ground, but those would get tied down at the ground end over here. The shield gets grounded at the source end, gets isolated at the far end, and now all we need to do is take in the rest of our lines. So this black line, actually, we'll change that to a dark blue. We'll follow the European blue for negative, so it's easier to read on here. We're going to take that into there, and we're going to go and take this positive output that we are going to have goes up over there. And so that is going to be a direct 4 to 20 milliamp that I can feed out to a field device. In some cases, you might have field devices that can't take 4 to 20 milliamp, but they can only take 0 to 10 volt. If you do have something that can only take 0 to 10 volt, you could never feed it directly off like that. That would be a bad time. We cannot go and do that. What we can do instead is we can go and use one of these. It's an RMCN22BD. Now, there's a whole family of these, and what these are is they're an analog voltage and current converter. So we can go and feed something into this converter. In our case, we can feed in 4 to 20 milliamps from the PLC. So PLC, just spell that PLC. We can feed in current. And then out of this, we can then go and feed out voltage to my field device, whatever it's going to be. And that's what we'll do. We'll take a PLC current conversion, we'll convert it to a voltage version so that we can run that out. Going back to here, if we take a look at the inputs and outputs that we have off of this device, the analog to voltage converter, I see I've got 3 terminals labeled with an I. Up top here, 3 terminals labeled with an O down here. PG is going to be protective ground or earth or negative, whichever you prefer to call it. These 2 are going to be inputs, so I can take current into this device or I can take voltage into this device. We're going to be taking current from here and feeding it into our device. And then out of this device, I can take voltage out to feed my field device. So we'll zoom back out so we can see everything again, and we will make those connections. First thing we're going to do is we're going to start with our cable. And we will take our cable and we will apply its ground and its shield or drain or screen, whichever you prefer to go and call that. And then we're going to go and now feed from my PLC to my analog converter. So I'm going to go to the input side because I'm taking something into it. So I'm going to go from here to my input side, and this one here goes to the PG or to the earth signal that I'm going to go and have. Then I'm going to go and take a current signal from here. I'm going to run it to my I side of this one over here. So we'll run that in like so. We have now taken 4 to 20 milliamps into this analog to analog converter, and we are going to go and take a take a 0 to 10 volt signal out as voltage. The V would go to the volts over there. The black or the negative would go to the PG protective ground. And there we have it. Now we have completely used our 4 to 20 milliamp output. In one case, taking that directly out to our field device. In the other case, taking it through a converter and then out to my field device. That is it for the TMC2 AQ2C.